Hello friends, I am Dr. Jagdish Bansal, Assistant Professor in the Department of Mathematics, Faculty of Mathematics and Computer Science, South Asian University, New Delhi, a university established by member nations of SAARC. Today I am going to discuss first introduction of optimization. Optimization is very useful in day-to-day life to the advanced research level. Euler said that nothing takes place in the world whose meaning is not that of some maximum or minimum. So, from this quote we can understand how optimization is important. What is the optimization? In a very lucid simple language, optimization is actually a mathematical discipline that concerns the finding of minima and maxima of functions subject to so called constraints. So, whenever you discuss an optimization problem, you are dealing with a function and some corresponding constraints. A general nonlinear programming problem can be defined as there is a function f(x) which is to be minimized or maximized. I have mentioned here only minimize, but it can be of maximization problem also. This particular function in terms of the optimization is known as the objective function. This objective function, minimization or maximization of this objective function is corresponding to a set of constraints which are denoted in the red text. Gix is greater than or equal to 0, I varies from 1 to m. So, there are m inequality constraints, these are the inequality constraints, and the next set of constraints is the equality constraints. So, in this particular example we have considered p equality constraints, and the design variable, this x is known as the design variable or the decision variable, and this is a n tuple in the real space, Euclidean space Rn. So, a general nonlinear programming problem, this is the general structure of the general nonlinear programming problem, which consists of an objective function and set of constraints, inequality constraints or the equality constraints. Related to the general nonlinear programming problem, a big issue is the local minima versus global minima. The solution of this general nonlinear programming problem are twofold. The solution may be a local solution or a global solution. We are particularly interested in global minima or global optima, because in general the problem may be of minimization or maximization. So, in general we can call it global optima. In this particular case, the red triangle mentions the global minima while the blue triangles mention the local minima. So, most of the deterministic algorithms available in the literature or the classical algorithms finds the global minima, and it is really very difficult to find the global minimum for a general nonlinear programming problem, and therefore there are many other heuristic or advanced random search based algorithms which finds the global minima probabilistically, stochastically. This is one type of optimization problem, that is a convex optimization problem, and in general language it is called convex programming problem. For this particular convex programming problem, it is to mention that the local optima and global optima coincides, means there are no local optima, there is only one global optima. In the convex programming problem, the objective functions remain same. The only difference is that the objective function is now a convex function, and that is must, and the set of inequality constraints, this Gix is greater than or equal to 0. So, this Gix must be concave. I hope you understand that the concave function Gix is said to be a concave if minus Gix is a convex set. So, if these inequality constraints are written in the form of Gix greater than or equal to 0, then this Gix should be concave, but if they are written in the form Gix less than or equal to 0, then Gix should be convex, and the equality constraints Hix should be linear. Then this particular form of a nonlinear programming problem is known as the convex programming problem. It is to be noted that this function fx may be a nonlinear function, but must be a convex function. So, this is actually a special case of nonlinear programming problem. Convex programming problem is a special case of nonlinear programming problem. Another special case is a linear programming problem. With respect to certain constraints, a nonlinear programming can be reduced to a linear programming problem. Subject to a linear programming problem also, the local optima and global optima are same, means there are no local optima other than the global optima. In this case, the objective function fx which is defined earlier must be a linear function, and as mentioned in the last lecture, this linear function will automatically be a convex function. So, this linear programming problem can also be treated as a special case of convex programming problem. So, f(x) is a linear function here in this case. The inequality constraints g(ix) should also be linear. So, they are again a convex functions. h(ix) are obviously should be linear functions. So, objective function, inequality constraint function and the equality constraint functions all should be linear, then this particular form of the optimization problem is known as the linear programming problem. Another kind of optimization problem is integer programming problem. In this case, the objective function is linear as in the linear programming problem. This consists of the similar inequality constraints and the equality constraints. For the inequality constraints and inequality constraints, the functions should be linear in the both cases. The only big difference in this integer programming problem and the linear programming problem is the nature of the decision variable x. So, here this x must be an integer. So, x belongs to Zn. So, this x is an n tuple where all the coordinates in this x vector must be an integer, while in the linear programming problem x, all the coordinate vectors in this x vector may attain the real values. In a broad aspects, the optimization problems can be classified as below. If we consider criteria constraints, availability of constraints, then if the optimization problem consists of some constraint, then the problem is called constrained optimization problems, but in nature there are certain optimization problems which do not have any constraint, only the objective function subject to some restrictions on the decision variables. Those optimization problems are known as the unconstrained optimization problem. If you consider the criteria nature of decision variables, then the optimization problems can again be classified into two parts: static optimization problem and the dynamic optimization problem. In the static optimization problems, the decision variables are always constants, while in the dynamic optimization problems, decision variables are the functions of some parameters. If you consider the criteria physical structure of the problem, then the problems can be classified into two parts: optimal control problem and the non-optimal control problem. If you consider the nature of the equations involved in the optimization problem, then the optimization problems can be classified into four parts: nonlinear programming problem as mentioned earlier, geometric programming problem, quadratic programming problem and the linear programming problem. If you consider the criteria permissible values of the design variables or the decision variables, that is x. So, if this x is an integer in the optimization problem, then the problem is known as the integer programming problem, and if this x, decision variable x, can attain the any real value, then the problem is known as the real valued programming problem. If you consider the deterministic nature of the variables, so if the decision variables are stochastic in nature, then the problem is known as the stochastic programming problem, and if they are deterministic, then the problem is known as the deterministic programming problem. Optimization problems can also be classified based on the separability of the function, of the objective function. If the objective function is separable, if the objective function and the constraints functions are separable, then the problem is known as the separable programming problem, and if not, then the problem is known as non-separable programming problem. If you consider the number of objective functions, it is to mention that the optimization problem not only consists of one objective function, there are certain optimization problems where you need to optimize, minimize or maximize, or one function is to minimize or one function is to maximize simultaneously. So, there are cases where you need to minimize, optimize more than one function simultaneously. Those particular type of problems are known as multi-objective programming problems. So, if you consider the number of objective functions in the problem, then the optimization problems can be classified into two parts: single objective programming problem and the multi-objective programming problem. Thank you very much.